Our goal is nothing less than to understand how this forest works. That's going to take many years, many scientists.
After you're gone, that there's going to be people coming out and measuring it, going to the same tree that you were at.
This is Yosemite National Park, a vast expanse of forest land and some really breathtaking views. When I came here 10 years ago, I met with a group of scientists just embarking on a long-term project to track the life histories of these trees, some of the oldest and tallest in the world.
We've understood from previous research that the number of large diameter trees is less than it used to be. And what we'd like to do is investigate why that is.
Jim, I've come back after a decade to see how things have changed.
It's a long time, isn't it? It has, 10 years.
How's the plot? It's right down there, isn't it, if I remember rightly?
Just a kilometer away are the 35,000 trees.
Well, we should go and have a look.
Let's do it.
Let's go. The tree right over there is the same tree that we filmed.
So here we can see the tag, same tag as what was fresh 10 years ago, and we can see the discoloration by the heat of the fire.
The park embraces science and the role of fire to manage the forest year-round.
5 years into the project in 2013, we experienced a fire, a backfire that the National Park Service lit to check the advance of the rim fire, at the time the largest fire in the Sierra Nevada of California.
This is Quercus cologii, California black oak. So today my role is to remeasure all of the trees that are alive to compare it to the measurements that we took right after the fire. The year after the fire, my first year here, a lot of the trees died, especially the small ones, as a direct result of the fire. And now we're starting to see some more delayed fire effects.
We've learned that the process of tree death is very complicated. It's never one thing. The fire certainly killed a lot of the smaller trees. The fire did not immediately kill any of the larger trees. Following the fire, we had 2 very, very strong drought years, very, very dry. We had a beetle outbreak of several species of beetles, which successfully killed a lot of the trees. And it's really this combination of factors that provide a situation that the trees can't resist well.
The forest just changes really fast, and it has really surprised me how every year we come back and we notice things are different. We remember that tree and that tree is no longer standing, or that tree and that tree just died. And so just the rate of change is pretty amazing to watch.
And you set out with many goals, one of which being to try to figure out why some of these trees are dying before they should. They're dying too young. Do you feel as if you're any closer to answering that question?
You know, even in the 10 years that we've already been studying it, we still don't know enough to track the reasons why those rates of tree death might be changing. We're just starting to be able to understand drought effects. We're just starting to understand how the beetles kill trees in patches. We've had very promising early results, but it's still an ongoing process.
If you were to come in and just look at things for a couple of years, you really wouldn't be able to get the whole picture. And so I feel very privileged to be part of something so long-term.
This plot is a very special place, and one that I foresee returning to for as long as I can walk up the hill.
These forests live for many, many centuries, if not millennia. And so it's important that research into these forests continue beyond the career of any one scientist. More than that, it's important that we as forest scientists study forests all over the world, because forests are so important to our civilization and in fact our planet.